All right, we're going to talk about how new substances are formed. We're going to be discussing chemical reactions and the types of chemical reactions that we'll be dealing with this year. When chemical reactions occur, all right, both chemical bonds between atoms are created, and that results in a new arrangement of atoms. Okay, atoms never disappear. All right, they're just converted into different substances, or basically would be a new arrangement of atoms, and that's where we get what we call this law of conservation of mass. Okay, the law of conservation of mass states that the mass of the reactants is equal to the mass of the products. Well, what the heck does that mean? It means that however many atoms are on the back side of the yields arrow, remember that yields arrow, is going to equal the number of atoms on the front side of that yields arrow. Okay, so the reactants equals the products and byproducts, if you remember that from our other aim. All right, and we use this law to balance equations. We're going to discuss balancing equations in a later video, but so for today, let's just look at this particular chemical reaction. You have hydrogen molecules and oxygen molecules, and when they combine, they go through a reaction and they form water molecules. But if you counted up the number of atoms in the reactants, you would notice that there's not as many on one side as the other. All right, you would find that there's 2 hydrogen here and 2 oxygen here. But on the product side, there's 2 hydrogen, and only 1 oxygen. So that's an unbalanced equation. So what has to happen is there has to be more of one of the 2 molecules. Okay, and you'll see the correctly balanced equation for the formation of a water molecule would be 2 H2 molecules, plus 1 O2 molecule yields 2 water molecules. Okay, and if you counted them up, you'd find that there's 4 hydrogen here and 2 oxygen. And on this side, if you remember the distributive property of the coefficient, 2 times 2 is 4 hydrogen. Did it again. And 2 times 1 oxygen is 2 oxygen. And you'd see that there are equal numbers of reactants and products. Okay? Now, the types of chemical reactions we're going to discuss today include a synthesis reaction, which is when you basically have 2 smaller pieces, all right, and they react with one another to form a larger molecule. So 2 small molecules react to form a large molecule. A decomposition reaction, which is when you have a big molecule and it reacts and breaks apart into 2 smaller pieces. Okay? Then we have a combustion reaction, which involves a carbon-based fuel, or the ones we're going to be looking at, a carbon-based fuel reacting with oxygen and releasing energy and giving off carbon dioxide. A single replacement reaction, where you usually have 1 compound present and 1 lone element, and basically that lone element switches places with one of the elements in the compound. And then a double replacement reaction, where you have 2 compounds and an element from each compound switches places, and you have 2 new different compounds. Okay. Now the first one is a synthesis reaction. A synthesis reaction, like I said, is where you combine more than 1 reactant to form a single, more complex compound as the product. So you have the small reactant A plus the small reactant B, and that yields a large molecule product, AB. Okay, and we use generic symbols here, A and B. Although B is a symbol for boron, we're just going to use it as a generic symbol today. Okay, so 2 materials come together to form a single product. You see this in the reaction we just spoke about in the formation of a water molecule. You have 2 smaller hydrogen molecules and an oxygen molecules to form two large water molecules, and that's synthesis. And one way, just so you know for the future, synthesis means to make. All right, the term photosynthesis means to make something using light, to make food, to make glucose. Okay. Another reaction we're going to discuss is decomposition. Okay, in a decomposition reaction, a single large reactant breaks apart into two or more products. Okay, so you'll see this using the generic symbols once again. You have the large molecule, and it goes through a reaction and breaks apart into two smaller molecules. Okay, it decomposes, breaks apart. You see there this is an example where you have potassium chlorate breaking apart into potassium chloride and oxygen. So you have this large potassium chlorate molecule, and it splits apart and forms two smaller compounds, potassium chloride and oxygen. Okay, another example would be sodium bicarbonate breaking apart into three different smaller pieces. So you have the sodium bicarbonate breaking into sodium carbonate, water, and oxygen. So you have three smaller molecules being formed by the breaking apart of that one big, huge sodium bicarbonate. Okay, and that's called decomposition reaction. Go. In a combustion reaction, we discussed, it's when you're going to have a fuel, usually a carbon-based fuel, reacting with oxygen. Okay, so fuels are usually contain carbon and hydrogen together. They're basically an organic fuel. Okay, it combines with oxygen to produce energy and give off carbon dioxide and water. Okay, so you have the fuel plus oxygen, and you'll see down here we have a carbon-based fuel. I believe this is called azulene. I don't know if the pronunciation is correct. Azulene. All right, and when that carbon-based fuel reacts with oxygen, it produces carbon dioxide, water, and energy. Okay? You could easily, CH4 is a common gas that you know as methane. All right, a lot of cows produce it. Some humans. Okay, in our single replacement reaction. Okay, in a single replacement reaction, you have a single uncombined element that replaces another element in a chemical formula. So if we're using a generic formula, you would have A, and AX is the compound. And what happens is Y is the single element, and Y basically replaces the A in one of the elements in the compound. So Y switches places with one of those elements. Okay? Okay, you can see it another way. It's basically the same thing. Okay? And our example that it will give you is zinc and hydrochloric acid. All right, when they react, okay, the zinc basically takes the place of the hydrogen, so the hydrogen gets kicked out of the compound. The zinc joins into the compound, and it forms zinc chloride. Okay, so you have zinc plus hydrochloric acid, and it produces zinc chloride and gives off hydrogen as a waste product. Okay? Okay, so in a single replacement reaction, one reactant is always an element. Okay, it does not matter if the element is written first or second, all right, on the reactant side. The other reactant will be a compound. Okay, so you're going to have a lone element and a compound. And then on the other side, you're going to have a compound and a lone element. Okay? All right, then we have double replacement reactions. In a double replacement reaction, parts of two compounds switch places to form two totally new different compounds. So using the generic formula like you see here, you have compound AB. Okay, let me get my pen going. You have compound AB and XY. And what happens is Y switches places with B and vice versa. So you have a double replacement. So Y replaces B, B replaces Y. That's the double replacement aspect of it. Okay? So the outside, you can see what happens here. Okay? Another example would be when, let's see, silver nitrate combines with sodium chloride. Okay? Two new compounds, sodium chloride and sodium nitrate, are formed. Okay? And that's because the sodium and silver switch places. And I'll draw that up right now. Okay? So you have AgNO3. This is silver nitrate. Okay? And when that reacts with what we know as salt, sodium chloride, okay, NaC, got to forget the rest of the formula, it yields silver chloride, which is AgCl, and sodium nitrate. Okay, which is NaO3. So now you can see this the sodium nitrate, the silver nitrate became the silver switched and became silver chloride, and the sodium switched and became sodium nitrate. All right, so then you have silver chloride and sodium nitrate. And that's the double replacement aspect of this reaction. So in a double replacement reaction, there are always two compounds as reactants and two compounds as products. But the products are going to be different from the reactants because you have the double switch of those elements that are in those compounds. There are no single atoms in a double replacement reaction. Okay? All right, please take any notes, any questions you have, write them down, and please bring them in to see us, and we can discuss this in class, okay?